to find Carl Pearson's correlation coefficient. Then also we know that formula to find regression coefficient B.Y.X is covariance of xy upon standard deviation of x bracket square. Then formula to find regression coefficient B.Y.X is covariance of xy upon standard deviation of y bracket square. So we have to find relation between r B.Y.X and B.Xy. So for this, first we consider product B.Xy into B.Y.X, and this is equal to covariance of xy upon standard deviation of y bracket square into covariance of xy upon B.Y.X is standard deviation of x bracket square. So this is equal to covariance of xy upon standard deviation of x into standard deviation of y whole bracket square. And suppose this is equation star. From star we can write this as r square from star. So r square is nothing but B.Xy into B.Y.X. Therefore r is nothing but plus or minus square root of B.Xy into B.Y.X. Note if both B.Xy and B.Y.X are positive, then r is positive. And second note, third note, this r is always lies between -1 and +1. r is always lies between -1 and +1. Then we find a relation between r standard deviation of x, standard deviation of y, B.Y.X and B.Xy. So for this, first we consider B.Y.X, and this is equal to covariance of xy upon standard deviation of x bracket square. If we multiply this by standard deviation of y and divide this by standard deviation of y, so standard deviation of y upon standard deviation of y is 1. So covariance of xy upon standard deviation of x into standard deviation of y. Take this standard deviation of y here inside the bracket and take one standard deviation of x outside the bracket. We get standard deviation y upon standard deviation of x, and we know that covariance of xy upon standard deviation of x into standard deviation of y is nothing but r. So B.Y.X nothing but r into standard deviation of x upon standard deviation of y upon standard deviation of x. And in notation form we can write this as Byx is equal to r into sigma y upon sigma x. Similarly, consider Bxy, and we know that Bxy is covariance of xy upon standard deviation of y bracket square. We multiply this quantity by standard deviation of x and divide this quantity by standard deviation of x. Similar to previous this problem, we get covariance of xy upon standard deviation of x into standard deviation of y inside this bracket, and standard deviation of x upon 1 this standard deviation of y outside this bracket. So this bracket quantity is nothing but r into standard deviation of x upon standard deviation of y. So Bxy is r into standard deviation of x upon standard deviation of y, or in symbolic form we can write this as Bxy is nothing but r into sigma x upon sigma y. This is our another formula. Then we take one example problem. Suppose this problem is given. For a bivariate distribution, x bar is 3, y bar is 5, standard deviation of x is 1, standard deviation of y is 2, and the coefficient of correlation r is 0.1. Find the regression equation y on x and estimate y when x equal to 2.5. Suppose this problem is given. From the given problem, we have to find regression equation y on x, and we know that general regression equation y on x is y minus y bar is equal to Byx into x minus x. So here first we have to find Byx, and we know that formula to find Byx is Byx is equal to r into sigma y upon sigma x, r into sigma y upon sigma x. So here r is given 0.1, sigma y is given, sigma y means standard deviation of y, which is 2, and standard deviation of x, which is also given, standard deviation of x is 1. So Byx is equal to 0.2, then 0.2. So y minus y bar is 5 is equal to Byx, which is 0.2, into x minus x bar. Here x bar is 3. So y minus 5 is equal to 0.2x minus 0.2 into 3. So y is equal to 0.2x minus 0.16 plus, so y is equal to 0.2x minus 0.6 plus 5 is 4.4. So this is regression equation y on x, and here second sub question is given, estimate y when x equal to 2.5. If x equal to 2.5, then 4. If we solve this, you get y. If we solve this, you get final answer 4.9. Then we take one more problem. Given the two regression equations as 4x minus y minus 23 is equal to 0 and 3x minus 2y plus 4 equal to 0. Find the mean values of x and mean value of y, and second subquestion is the coefficient of correlation. 4x minus y is equal to 23. Suppose this is our equation number 1. 3x minus 2y is equal to minus 4. Suppose this is our equation number 2. We know that if x and y are two variables, and then we have two regression equation x on y, and second is regression equation y on x. And we also know that these two regression equations coincide with each other at mean. Means if we solve these two equations for x and y, values of x and y are nothing but values of x bar and y bar. So first we solve these two equations. For this we multiply equation number 1 by 2 and then subtract second equation from equation number 1. We get multiply equation number 1 by 2 and subtract 2 from 1. We get, if we multiply equation number 1 by 2, we get 8x minus 2y is 46, and equation number 2 we write this as it is, 3x minus 2y is minus 4. And if we subtract this equation from the above equation, we get 5x, that is 0y is equal to 46 plus 4 is 50, means 5x is 50, so x is 10. Then we put x equal to 10 in any one of the above equation. If we put x equal to 10 in suppose 1, we get 4 into 10 minus y is 23, so 40 minus y is 23. Then second subquestion, second, for coefficient of correlation R, we solve this problem by trial and error method. First consider equation 1, which is 4x minus y is equal to 23 is the regression equation y on x. So we write this equation for y. So y is equal to 4x, y is equal to 4x minus 23. So from this we calculate regression coefficient, which is coefficient of x. Compare this equation with y is equal to a plus bx, we get byx is 4. Then consider equation 2, which is 3x minus 2y is equal to minus 4 is a regression equation x on y. So from this we calculate we write this equation for x. 3x is equal to minus 4 plus 2y. Therefore, x equal to 2 upon 3 into y minus 4 upon 3. So if we compare this equation with x equal to a plus by, we get our regression coefficient Bxy is 2 upon 3, and we know that formula to find rank correlation coefficient is r is equal to plus or minus Bxy into Byx. So here Bxy is 2 upon 3 into Byx, which is 4. So here both Bxy and By are positive, Byx are positive. So this value of r is also positive. So plus square root of 8 upon 3, and we know that this value is greater than 1. So our assumption is wrong, which is regression equation first is not y on x and regression equation second is not x on y. Then we consider regression. Then we consider equation first is regression equation x on y. So this is our equation number first. So if we consider this is regression equation x on y, means we have to write this equation for x. So for x is equal to 23 plus y. So x equal to 23 upon 4 plus 1 upon 4 into y. Therefore Bxy is 1 upon 4. Similarly, consider equation 2 is a regression equation y on x. So our regression equation, our second equation is 3x minus 2y is minus 4. So we have to write this equation for y. So 2y is equal to 3x plus 4. So y is equal to 3 upon 2x plus 4 upon 2. So from this we get Byx is 3 upon 2, and then use this formula and find rank correlation coefficient, which is r is equal to plus or minus square root of Bxy into Byx. This is equal to, here both Bxy and Byx are positive, so our value of r is also positive, and Bxy is 1 upon 4 here, and Byx is 3 upon 2. So square root of 3 upon 8, this is our value of r. So r is equal to square root of 3 upon 8. This is our final answer.